My name is Ed Lima, and I'm here with Brice Pella. This is Accelerate GraphQL API app development and collaboration with AWS AppSync. Well, we have a full house here today. It's great. Last time I was presenting at re:Invent. Actually, last time I was presenting to an audience with people in the same room. It was at re:Invent. After that, I had to record my sessions. They were presented online because of the pandemic. And as you know, the pandemic left lots of marks on people. We are in isolation. And some people carry those marks up to this day. Me, for instance, the pandemic hipster hair. I still have it. I'm still sporting it. It's good. I've been saving lots of money in the visit to the barbershop. So yeah, as I mentioned, last time I was presenting at re:Invent, it was in 2018. And coincidentally, I was co-presenting with Brice as well, and a session about AppSync. And coincidentally, there was a soccer game, Brazil versus Cameroon. So for those who don't know, I'm originally from Brazil. Brice is originally from Cameroon. We had a game back then. It was a friendly. It was also a World Cup year. And Brazil won 1-0. Sorry, Brice. And actually, we are now in the World Cup, actual World Cup again. And on Friday, there is a game, Brazil versus Cameroon, again. So it must be a sign. I guess every 4 years we have to come back here, Brice, and present and co-present. And the World Cup's great. I love it. I'm a big soccer fan. And it's an awesome sporting event. Anyone else following the World Cup? Yeah, lots of people. Brazil did well, won this week. Actually, this morning, Australia won. Any Australians here? Yeah, go Australia. Love that country. My son was born in Australia, actually. But yeah, people usually think that I can play soccer because I'm Brazilian. And that's not true at all. So last time I played soccer, I was in Brazil, and I was a goalkeeper. And I had to kick the ball to midfield from the goal. And I aimed, I pointed, and I just visualized the ball, and I kicked. The ball did this. So I did a goal against myself. Since then, I realized I'm very good at watching soccer, I'm very good at giving opinions. Everyone's a coach, but I'm not so good at playing soccer. So back in 2018, I mean, actually, 1 year before 2018, I was introduced to Brice. I was a solutions architect back in Australia, and Brice was a technical account manager in Texas. We've been working in AWS for a while, and we got contacted about testing this service. It was in alpha. It was supposed to be released at re:Invent 2017. And they contacted us about the service. The service had a code name. It was called Deep Dish. First thing I thought was like, oh, who actually give those code names? It's just a weird name. But actually, me and Brice, we saw the value of GraphQL and the service as developers. And we actually worked on a blog post with the first demo app for AppSync. It was a chat app in old Angular. Fast forward a couple of years, we kept working with AppSync. Fast forward a couple of years, me and Brice, we actually relocated to Seattle, and we became AppSync product managers. It's been a truly amazing journey, working backwards from our beloved customers, and working with an amazing team to develop and release features that actually fit our customer requirements and customer use cases. And we're here to talk about two at those features, the features that were actually very requested, and the team took a long time working on them, so I hope you all enjoy. And this is what we're going to talk about today. We're going to talk a little bit about APIs and how they evolved from the old days to what we have today. And the main themes are team collaboration and developer experience. But let's start from APIs. So APIs are application programming interfaces, as we all know, and they provide a way for applications to talk to internal or external systems or services. And they can be public or private APIs for transportation, location, weather forecasting, machine learning, and many other use cases. We live in an API world, actually. And it's widely used by developers. It all started in the days of the monoliths. Excuse me. So monoliths were an easy way to get started back then. You could basically collocate everything in a single system. It was easy to get started and iterate at the beginning. Also, the clients contacted that also single system, which the client could be Ling. But the problem is, as the system evolved, monoliths get bigger and they get brittle. And it's hard for developer teams to work on it because the deployment cycles are long because you need to do full application deployments. And also there is the question of scalability. Eventually you can scale vertically, and then you get to a ceiling, and that can affect the experience for users. So eventually, the monolith got broken into microservices. And that was great because we have different teams that could work on different services, and they evolved. And they could evolve independently with isolation, and they could also scale independently. However, on the other side of the equation, on the client side, things didn't look so rosy because the client complexity grew. They had to access directly all those services. So the client got bloated, and with having to call multiple services, doing joins, overfetching, underfetching data. So how could we actually get the best of both worlds? Because from the front-end teams, actually, the monolith looked pretty good. Not so much for the back-end team. So how can they get the best of both worlds? So come up with the concept of an aggregation layer, right? Where clients could reach that aggregation layer, and the aggregation layer was supposed to proxy and route requests to specific services. So basically lowering the complexity on the client side and allowing the backend side to evolve independently with the different services and different teams. Actually, that aggregation layer allowed to have maybe few APIs that could access those services. GraphQL is a technology that's very well suited to become an aggregation layer because everything is based on data. So GraphQL is a query language for APIs and a runtime to fulfill those queries. The great thing about GraphQL, again, is all based on data. So you can request data in a query. Your GraphQL layer is going to do the service discovery, the routing and proxying to the services. The client doesn't need to know if the data is in different services. So out of the box, it allows for a strongly typed system. And you can get all the data you need in a single request. Because again, the way it works, you query your data. The GraphQL engine contacts all the backend services and then receives the response and consolidates that response in a JSON payload, in a single JSON payload that sends to the client. Another powerful capability of GraphQL is real-time. So you can have built-in real-time notifications where whenever data is changed, for instance, an order is fulfilled or a chat message is sent, then you can get that sort of push system to push data to clients. So according to Gartner, the API market will grow to $27 billion by 2028, with more than 50% of the enterprises adopting GraphQL in production by 2025. So GraphQL it was created by Facebook and open source in 2015, and it's been very popular with developers. The interest has been growing because of the capabilities that GraphQL provide. And what's the best way to run GraphQL on AWS? Well, we could have a GraphQL server, but servers are so 2014. So AppSync is a service that allows you to build scalable applications on a range of data sources. And you can also have built-in real-time and offline capabilities, allowing to improve the user experience for your clients. Best of all, no servers to manage. Let's take a look at a specific example, right? Imagine an e-commerce system. So imagine you have 4 different services, a user service, order service, inventory service, so on. And they are stored, again, in different services. Back in the old days, clients would be hitting those services directly. So to get information they need to make 4 API calls to those different services. And then the client will need to do joins and consolidate the data. Probably will overfetch data because those services will be sending full payloads that they don't need. But with GraphQL and AppSync, basically clients can reach a single API endpoint that then looks at the query that the client requested and contact those services independently. The services then respond, and the GraphQL engine, again, constructs a consolidated JSON payload back to the client. Everything can be done with a single request, a single endpoint, and best of all, hiding all the backend complexity. The clients don't want to know and don't need to know where the data is coming from. So AppSync provides a serverless GraphQL service, one endpoint where you can query any data anywhere. And you can connect your application, your API, to multiple data sources. You can also provide powerful pub/sub capabilities where you can have you can connect millions of clients and push data to millions of clients seamlessly, scaling to any demand with broadcasting fan-out connection management built-in, and also using powerful clients such as the Amplify Data Store. You can have full synchronization with clients. So when clients go offline, the data is automatically synchronized when they come back online. So as we discussed, GraphQL is well suited to become an aggregation layer for microservices, because clients just need to perform a single call and data is retrieved from multiple microservices. Clients, teams, front-end teams, they can evolve their application independently from back-end teams and all the teams working on different services. But usually what we've been seeing from customers is they're seeing all the advantages of GraphQL and they want to use it as a organizational data graph API, where you can have single domains that are related and you expose in a single endpoint. When teams see that sort of capability and they want to join into the graph, what happens when you have multiple teams working in a single graph is they need to make changes to the GraphQL layer. They have to make changes to their schema. And teams eventually will end up breaking other teams if they all accessing and working at the same time in the same API. And what happens is we have a new monolith. So how can we solve this problem? Because when you have multiple teams working in a single API with multiple services, they want to collaborate, but most importantly of all, in a safe environment with proper isolation and proper ownership. So when you have multiple teams working in a multi-service environment, of course, teams, they need to, and they want to have development velocity. They have their own tools, their own deployment schedules. Some teams might want to deploy weekly, some teams might want to deploy daily. So they have to have independency and isolation. In Amazon, we usually say service teams should be 2 pizza teams. That's why smaller teams can iterate faster, and that's what you want on a microservice environment. However, there are dependencies. Maybe some services need data from other services. So it's also very important to have a proper collaboration environment without complexity. And how do you do that in a GraphQL environment? Because you can have different teams. Maybe you can have a GraphQL API for an orders service, and a team owns that service. And then there's another team that has a GraphQL API for a products service. So an order can have multiple products. And if those teams are isolated, then a client has to call the order service, get a payload, and then make a second call to the product service, and then get the details, and then construct that payload itself. That goes against the GraphQL motto, which is single endpoint, single request. So how can we solve that problem? Because at the end of the day, the solution is, again, how can I compose those multiple schemas in a single API where clients, again, just need to access that single endpoint? And that's the end goal. So there are 2 ways of doing this currently. One way is called runtime composition. Some people call federation. So we can have a central gateway that calls secondary APIs or backend APIs called subgraphs. And the gateway basically routes and proxies requests, but all the APIs are part of the GraphQL execution path. Problem there is just physics, because you have more network hops, and that can increase latency. Another issue with runtime composition is real-time subscriptions. So you cannot have, they don't support real-time subscription capabilities, which for some applications is essential. There's another way of doing this. It's called build time composition. So with build time composition, a single API is composed, as it says, at build time. So several teams, they deploy and commit their code. There is a build pipeline, a specific build logic that composes that the code and schemas and any changes into a single API, and then presents a single API endpoint to clients. As it's a single API, like a normal GraphQL API, real-time subscriptions are fully supported. The downside there is that you need to set up those complex deployment pipelines yourself. And earlier on this year, we published an RFC on GitHub about our upcoming feature, merged APIs. which is the AppSync way of solving that problem. We want to provide a build time schema composition without the complexity. So let's take a closer look at how it works. So let's first of all recap what are the main components of AppSync. So in AppSync, you have a GraphQL schema. That's where you model and define your data. It's a fully typed schema, and you can have types and fields, operations, and that allows type safety out of the box. There is also a built-in runtime component in GraphQL. It's called resolvers. So resolvers is basically the logical glue between the data defined in the schema and the data in the actual data sources. It can be databases or other APIs. And they're called resolvers because they resolve the data from the GraphQL schema with the data from the data sources. And finally, we have the data sources, which are where your data resides. So in AppSync, we have those three main components, which is GraphQL schema, resolvers, and we have actually a definition and pointers to data sources where the data sources are. So now imagine we have two teams, like I mentioned, orders and products. They all have their own GraphQL APIs in AppSync. And they all also hosted in different AWS accounts. So we have an order service here. They have their own GraphQL schema, resolvers, and they retrieve data from a highly scalable NoSQL database in the cloud. And the product team, another AWS account, another API, and they use SQL as a data store. So imagine those two teams are part of a merged API setup. So it can be merged APIs, it can be configured in a way that any change to your source API is committed automatically to the merge API, or you can disable automatic merging. So you can define when you're going to merge your definitions. And you can use the AWS console, CLI, or the SDKs and build your own sort of button to trigger a merging task or a merging process. After the merge is done, a separate API is generated with a read-only schema. The schema is composed automatically, and all the resolver definitions, all the resolver code is also ingested into the merged API. As you can see, the data sources, they are still where the data resides in their accounts, and the merged API accesses the data securely using IAM. And basically, there are no other APIs in the GraphQL execution path, which means there's no daisy chaining of APIs, and you can be more performance because you're accessing the data directly. We also providing special directives to be more flexible in resolving conflicts. Maybe there are types or fields of the same name in those different APIs, so you can use a directive such as canonical to define what type takes priority. You can hide specific types if you don't want them to be present in the merged API. And also if there is a need to rename specific types of fields or operations, you can also rename using the rename directive. So there are a couple of terms here, a couple of terms that you need to be familiar with, right? First of all, there's a merged API. Merged API is a single AppSync API that's results from a merged operation. So where multiple GraphQL schemas, resolvers, and data sources are imported. Source API is the source of truth. That's where each team works, and they have their own specific definitions. Source APIs are managed by different teams. They work in isolation, and the merge API is where all those teams collaborate. Teams cannot edit anything on the merged API as far as schema and resolvers are concerned. And how it works, it's actually very simple. You create a merged API in AppSync, And you basically add other APIs. It can be on the same account or a different account. So once you add those other APIs, you can imagine this is an invitation. As a merged API owner, I'm inviting your API to join our merge setup. And with the merged API, it manages the addition, removal, or updating of those source APIs. The source APIs themselves, they receive that invitation, and they need to set up specific IAM roles and permissions. After the IAM roles and permissions are properly configured, the source API can then trigger initial merge. And that's the way to accept the invitation from the merged API. And after that merge is successful, the APIs establish a unidirectional merge relationship. So the source API can send those changes to the merged API. If there is an error or an issue with the merging, the merge API supports breaking change detection and then just returns an error with a meaningful description of what happened and asking the source API owner to retry. So basically, you can have all those teams working in isolation, defining their own schemas, their own data models, and then AppSync takes care of the complexity of building and merging those schemas in basically generating a single API endpoint where clients can access the data in a very performant way because the data is accessed directly. The teams are still fully isolated. And then other teams can just onboard to the organizational data graph provided by the merged API in AppSync. Again, we're solving the problem with the aggregation layer because we're providing a single endpoint for clients. Client teams can evolve independently. And all the services, they have a GraphQL interface in AppSync where they basically work with their own stuff in isolation. So source API is the source of truth. Resources can be merged automatically whenever there's a change or manually. So imagine a team does deployments only Fridays, 5 p.m. I strongly recommend to have a better schedule, but to each their own. But that can be done if you just disable automatic merging, and you do your tests, and you know when you're ready to merge. Teams working for isolation, a source API A cannot access a source API B. So they basically have their own subset of schemas and resolvers that they work on in isolation. And source APIs are not part of the GraphQL path execution, the GraphQL execution path, which means you're not daisy chaining and you're not having extra network hops. Merged APIs is a single AppSync API, the normal single AppSync API. The only difference is that schema, resolvers, and the pointers to data sources are read-only. Everything else you can do as you can do in a normal AppSync API. You can enable caching, you can define authorization, you can enable WAF integration, you can enable X-ray integration. And the access to the data is fully secure by IAM. Also, real-time subscriptions supported out of the box. Again, it's a single API. So with merged APIs, AppSync checks all the boxes, allowing to provide improved development velocity, provide isolation, where every team owns their own data models, with simplicity. You don't have to worry about complex build pipelines. And if you go back to our stages of the API evolution, AppSync merged APIs are the next stage of the API evolution in a microservice in a multi-team environment. You can access our merged APIs RFC, and please provide us feedback. We love to hear from you. You love to hear feedback. Merge APIs are coming to a region next to you in AppSync in early 2023. And it's going to fully support the next feature that we're going to talk about now, JavaScript resolvers. So I hand over to Brice. Thank you very much.
Thank you, Ed. Thanks, Ed, for that overview. Really looking forward to seeing what our customers are going to be doing with merged APIs. As Ed mentioned, Brazil and Cameroon are playing this Friday, so watch out for that. I would say may the best team win, but Brazil is already on to the next round, and Cameroon really needs to win, so I expect everybody here to be cheering for Cameroon on Friday. So I want to switch topics now and talk about how AppSync is really meeting developers where they are and how we're allowing developers to do even more with GraphQL with JavaScript. So if you look at AppSync today, Ed talked a little bit about this, but resolvers are really at the core of what makes AppSync able to produce scalable APIs. AppSync is really the easiest way to connect to data sources today. It allows you to build a GraphQL API that connects to pretty much anything. For example, we have integration with services such as Amazon DynamoDB, so you can connect to Amazon DynamoDB tables really easily, or you could integrate with AWS Lambda functions. AppSync also makes it really simple to connect to any AWS service. You can do that by configuring an HTTP data source. So with an HTTP data source, you can configure it with the endpoint of your service, provide a role, and then when you make a query to access that data source, AppSync will actually sign that request for you using SIG-v4. This is actually a really great way of simplifying the interface that your clients interact with and then protecting your backend data services. With AWS Lambda, you can do things like proxying calls to other APIs. So if you've got APIs that live in your VPC or APIs that live on-prem, you can do that easily with AWS Lambda. And you can also use Lambda function to interact with things like databases that need to use drivers. With AWS Lambda, you can do things like batching requests as well. And you can do this without writing a single line of VTL code. So the main thing that we're trying to do with AppSync is make it easy to build APIs, but also allow you to focus on the work that you want to do without having to manage that infrastructure. If you look at how AppSync works today with resolvers, Ed talked a little bit about this. We've got a schema. Schema is where you define your data types. And then on the right, we've got data sources. This is where your data lives. And in the middle, you've got what we call resolvers. So resolvers, as the name suggests, resolve the queries that come into your API. So essentially, when a query comes in, the resolver takes the context, the information about that query, and then executes transformation logic that tells AppSync how to interact with your data source. One of the really nifty features that we have in AppSync today is what we call pipeline resolvers. Pipeline resolvers allows you to access multiple data sources to resolve a single query, a single request. This would typically be pretty hard to do, but it's actually really simple with pipeline resolvers. A pipeline resolver is composed of multiple functions. You can think of a function as the individual unit of compute that runs your business logic in AppSync. It's like a subroutine, and each function can interact with a specific data source. The interesting thing about data sources, about functions, is that you can reuse functions across multiple resolvers. So for example, if you have a situation, which I've seen a lot of our customers do, where you want to access something in a parameter store to retrieve a secret, maybe you need to retrieve that secret for multiple queries, you can reuse the same function in multiple resolvers, and you don't have to rewrite that functionality every single time you want to do that. So when a query comes in, your pipeline resolver is called, and your functions are run in sequence. So you've got a first function that is called, second function, third function, and so on. And then ultimately, your resolver is responsible for taking the result of your last function and transforming it into something that makes sense for the request that is actually being executed. So functions are pretty powerful. Now, if you've used AppSync, if you're an AppSync fanatic out there, you've probably used functions and you've used VTL. But a lot of times, people don't really think about what a function's role actually is in our system. And as the name suggests, the function is simply a subroutine that knows how to take a context and work on that context, execute transformation logic and business logic and authorization rules to return a specific result. It is what it's actually called. It's a function. So your function takes your transformation logic and then tells AppSync, based on what I'm seeing, this is the data that you should fetch and this is how you should fetch it. It does this by interacting with the context object, and the context object has contextual information about the query, the request that we're currently operating on. So your context is going to have information about the identity, for example, of the principal that's making the call. It's going to have information about the field that is being resolved. It's going to have information about the arguments that were called to resolve, that were called when the query or the mutation was made. This is a really important concept that I'll come back to later. Now, up to this point, the only way you've been able to really write these functions is by using VTL. Show of hands here if people know what VTL is. A couple of people. Okay, so and show of hand if you are a VTL fan in the room. This is your favorite programming language. Not so many hands, I'm surprised. So VTL stands for Velocity Template Language. It's essentially a templating language that allows you to run custom transformation logic, and this is the language that we've been using in AppSync to write your functions and your resolvers. Now, I think that in a way, VTL gets a bit of a bad rap. It's actually pretty powerful, and it allows you to do some really interesting things at runtime when you execute your business logic. But the reality is that we've received a lot of feedback that VTL is hard to use, right? And because VTL is a language that is not really well known, it's really made it hard for developers to onboard to VTL and to do the work that they want to do. What developers have told us over and over again is, give us another option, give us something else that we can use to write our business logic, and if you can, please make that language JavaScript. So that is what we did. Last week, we introduced support for JavaScript in AWS AppSync, and we introduced a new runtime that we called the AppSync.js runtime. The AppSync.js runtime is a custom-built, purpose-built custom runtime that we built to run within an AppSync context. It allows you to use JavaScript directly to write your functions and resolvers, and it also allows you to use TypeScript on the client side, bundle that code, and then upload it with your function configuration or your resolver configuration. To build the runtime, it took us quite a bit of time. And what we did is we listened to what our developers, our customers, and our builders wanted to have. And we took some time to build a runtime that we knew would run efficiently and with high performance within AppSync. It was really important that we build a runtime that would be performant and behave in a consistent way in a multi-tenant environment and in a serverless manner, right? So we definitely wanted to make this something that is serverless. So to do this, we did have to make a couple of compromises to make sure that it was efficient, performant, secure, and work in a multi-tenant environment. What that means today is that when you use the AppSync.js runtime, not all your typical JavaScript functionality is supported. There are some things that we don't support today in the runtime. But the thing that is really important to note is that this is only day one for the runtime. We are definitely not done building on top of this runtime, and we have a lot more functionality coming. So as you can see here, we have an RFC. The QR barcode here leads you to the RFC on GitHub. We are still listening to what the builders want. We're still taking feedback, and we want to know what you want to see next into runtime. What is the type of functionality that you would like to see? That being said, even with these runtimes, I think there's a lot of benefits that developers are going to be able to enjoy with JavaScript. For example, the fact that we have very low latency because this code is running directly within AWS AppSync, and there's no additional cost to running this runtime. This is something that you're just getting as part of AppSync is that you can use today. You don't have to deploy any more infrastructure to make use of it. We really wanted to make this as efficient as possible. We wanted to allow developers to write less code, write directly what you want, directly what you know, while using all of the functionality that AppSync provides today. So you can write your code in JavaScript, but you don't have to worry about handling authorization. You don't have to worry about handling caching, or you don't have to worry about security. These are still things that AppSync does well and that you can leverage today within your JavaScript code. We want it to be less complex. In a lot of situations, if you're going to build a GraphQL API from scratch, there's going to be a lot of functionality that you've got to bring in yourself or that you've got to implement. We often talk about subscriptions. These are things that are really, really hard to implement, but you get them at no additional cost when you use our JavaScript resolvers. And we wanted it to be less expensive, less cost, no more additional infrastructure to deploy. The key thing here is we want to make sure that we empower developers to write the business logic that they need without having to worry about managing services. So what does that mean? What have we changed? If you look at AppSync as a service, overall, the execution and the makeup of the service when you look at it or when you interact with it hasn't changed. We still have our pipeline resolvers, but now instead of writing your functions using VTL, you can write them in JavaScript. You can also mix and match. So we understand that we have a lot of customers today that have been using VTL, but you can mix your VTL functions with your JavaScript function. So you can have a pipeline resolver that uses VTL functions and JavaScript function. You can have a pipeline resolver written in VTL that uses JavaScript function. So all of these are things that you can mix and match. And so the hope here is that if you're already using VTL, you have a path to migrate your code to a JavaScript-based implementation, but you can take your time. If you've got a VTL routine that is pretty substantial and that has business-critical code, you can start leveraging that code and surrounding it with JavaScript functions while slowly chipping away or transforming it into JavaScript. So how does it work? Well, with JavaScript resolvers, we say goodbye to mapping templates, so there are no more mapping templates to provide. We are introducing a new property, a new attribute to your function configuration and to your resolvers, simply called code. All you have to do to use JavaScript is supply your code. And in that code, you want to provide two things, two functions that you export that we're calling handlers. You want to provide a request handler, and you want to provide a response handler. And this kind of goes back to what I talked about when I talked about what is the nature of a function in AppSync. Your request handler is called with a single argument, which is the context, and your request handler is responsible for generating a request object that AppSync is then using to interact with your data source. When the request has been executed, AppSync will then call your response handler with the same context object. The main difference here is when your response is called, the context will now have a property called result, which has the result of your data source access. And that is it. It's pretty simple to write. And this is just JavaScript code. There's nothing special going on here. You're just writing your own JavaScript code. So what did we include in the AppSync.js runtime? I think the majority of the functionality that you're used to in JavaScript today is available. A lot of the stuff that you've seen in ES6, so we've got baseline support for things like Boolean numbers, arrays, functions. Yes, you can write functions and you can reuse functions. Your typical flow statement control that you're pretty used to, if else, for loops, for in, break statements, ternary, coalesce, and so on. So all of these things are there. We've got support for built-in functions as well on objs, string arrays, and so on. I did mention that you can write your own functions, which is pretty important feature as well. And things like destructuring, so if you're working with objects or if you're working with arrays and if you want to access things within an array, you can do that. Spread arguments and stuff like that are also supported. So all of the basic things that you need to do work with JavaScript. So what does it look like, a before and after picture? Here's a very simple example. We have a VTL code. We have a request mapping template and a response mapping template. This is what we used to do before. Now with JavaScript, like I said, no more mapping template, you just have your JavaScript code. All you need to do is export a request function and a response function, and you're ready to go. This is a pretty simple example. Here's another example of some VTL and some JavaScript. Now, the point here is not to put these things side by side and say, look at how different it is. But it's interesting to note that the code that you see on the left is essentially a snippet of VTL code that comes from some code that is used to create an update item request to update an item in DynamoDB. And there's a lot going on there. So if you're not familiar with VTL, this is kind of hard to grok. And you can see that there's a lot of manipulation that is done that may not be easy to understand. On the right, you've got essentially the same logic, but you're starting to see constructs that you are probably more familiar with. Object, arrays, using join, concatenation, for loops, destructurings. These are the type of things that makes working within AppSync with JavaScript a lot more pleasant. You'll also notice that there's a lot less code. And I think we all know that less code doesn't always mean that it's better code. But one of the things that we're starting to see is that it does take a lot less coding, a lot less lines of code to produce the same result, which is a good thing. That's what we want it to be. We want it to be less complex and more straightforward. Now, supporting JavaScript is great, but we also want to make sure that developers have a great experience when they're using this. So we definitely wanted to focus on the development lifecycle and make sure that developers could code properly without too much frustration, right? Making sure that you have the right tools to do what you need to do. Making sure that you can test your code, whether it is unit testing or whether it is doing end-to-end testing. We also wanted to make sure that you could debug your code. Now, this is something that we've heard quite a bit about from developers. Give us a better way of debugging our code, whether that be when we're testing it or when we are running it in production. Help me understand what is going on. Help me get a better sense of what is happening in the logs. So in order to do that, we are releasing a couple of utilities with JavaScript resolvers. The first thing that we're releasing is a utility that you can go and download on NPM, so there's the barcode here. And this utility essentially gives you access to all of the utilities that are available for your JavaScript resolvers. It also provides some type definition, and we started with a couple of type definitions today, but if you want to use TypeScript on your client side, you can use those to get started. The thing about utilities here, one of the things that we saw when we analyzed some of what our customers are doing with ETL, a lot of time our customers were running into issues simply because they were mistyping utilities. So there were a lot of situations where developers just had typos in their code. And because VTL is hard to test, the code was never tested, and they would only encounter those issues in production. By using something like a library where you have all of your utilities defined with documentation, we can do away with a lot of those type of errors. So it helps you write proper requests. The other thing to note is that when you save your code to AppSync, we will actually double check your code to make sure that you're only using utilities that are well defined. So we will warn you when you're using something that is not defined within the system. The main thing that we're trying to do there is make sure that we can catch errors early so that you don't have to deal with those errors in production. We're also releasing an ESLint plugin. And again, the ESLint plugin here is to support you while you code in your IDE. So for example, if you're using VS Code or if you're using something else, you can use this ESLint plugin. I mentioned earlier that the runtime does not support every single piece of functionality in ES6. So the ESLint plugin that we provide has a couple of rules that catches some of those things that are not supported. One of the things that we don't support today is unbounded loops. So if you try to do something like while true, this is not supported. Now, if you were to try to save that code to AppSync, we would catch that. But it's even better if we can warn you ahead of time before you even try to save it that it's not supported. The other thing that we don't support is returning function declaration from within functions. So those are the type of thing that this ESLint plugin can help you with. And then finally, to improve testing, we support your typical favorite logging and debugging functionality, which is console.log and console.debug. And this is pretty handy. You can use this within your code. Console.log and console.debug is integrated with CloudWatch logs. So when you run your code in production, those logs immediately go to CloudWatch logs and you can find them there. Those logs are also come with the location of where the log statement occurs. So it's a lot easier now to kind of understand what is going on in your code. And because those log statements are integrated with AWS AppSync, they also respect the logging level that you set on your APIs. So it's a lot easier to understand and debug your code. We're also providing a new command called evaluate code. And this is a command that you can use to essentially test your functions with mock data. And when you test your function with mock data, we will also evaluate your code just as if it was being evaluated in the AppSync system at runtime. So you can use this from your command line, you can use this from within your testing framework, you'll be able to see all of your logs, you'll be able to validate your code. So again, we're trying to help developers validate and verify their code way before it gets into production. So this is what you will see in CloudWatch logs. Your logs will be just there. The other thing that this helps with is you can easily print JSON objects here as well. So if you want to print things out and use CloudWatch logs to create additional metrics, you can do that. We're also improving the way we log the evaluation result of your functions. So before, if you had used AppSync, you've seen that we would just kind of print out a random string that was really hard to read. Now we have a clear evaluation result that you can see. It's really clear, makes it easier to kind of understand what is going on. The other thing that we're really excited to see here is calling an AWS service. As I mentioned earlier, you can use HTTP data source to call any AWS service. And I think this is going to be something that is a lot easier to do with JavaScript resolvers because you can use functions. So you can write functions that you can reuse. One of the things that I'll mention is while we do support imports in our runtime, all of the imports that you use have to meet the requirements of our runtime. And I think in a nutshell, what this means is that your typical NPM library that is out there, like say if you wanted to use Lodash or something like that, those libraries are probably not going to work with AppSync.js today because those libraries are using some constructs and functionality that we do not support. However, that does not stop you from writing your own libraries that you can then import and reuse in your own code. So, the last question that you may have here is, okay, this is awesome. I've got JavaScript support in AWS AppSync, but I've also got my Lambda function that I used to use quite a bit. What should I do? And I'm going to answer into typical AWS Amazonian way, and I'm just going to say it depends. It really just all comes down to what are you trying to do. Now, I do believe that in 80 to 90% of the situations, JavaScript resolvers are going to be more than enough to implement the business logic that you have. But Lambda functions are still your friend, and they're still here, and you can still use them. So it really just comes down to what are you trying to do. If you have got logic that is really complex and that requires a lot of external dependency, you should probably still use a Lambda function. If you're trying to use another language, if you want to use Python or Java, you should use a Lambda function. So hopefully the table here kind of helps you understand some of the differences. The main thing to remember is that they are both here for you to use. So you just need to kind of evaluate what you're trying to do and use the most appropriate data source or option for you. Okay, so we've got a bit of time left, and I wanted to show a little bit, maybe do a bit of a demo and show how some of this works. Make sure I get this right. So, in the spirit of the World Cup, last night I built a quick app to kind of showcase some of the stuff that I want to talk about today. You can use the QR code to go to this app. This is simply an app that you can use to cheer for your favorite team. I think I've got internet connectivity here. Let me make sure. You can use this app to cheer for your favorite team. So what does the app do? It's a very simple application, but it uses JavaScript resolvers. If you look on the right here, we've got the application, and the application is a Next.js application, really simple. It allows you to vote for your favorite team, Your vote comes in, it uses a pipeline resolver that has multiple functions. Okay, wow, that's a lot of stuff coming in there. And it does three things. First, it goes to SNS. So let's say a vote comes in and you want to send it to a third-party system for a further evaluation. You can do that easily by sending it to SNS. SNS will send it to a Lambda function or whichever subscriber you have. Then it saves the actual vote to DynamoDB. That's the second function. And then the last thing that it does, it goes to AWS Translate to translate the message, right? Does this all in function, doesn't need to use any SDKs or anything like that. And then the last thing that it does, this triggers a subscription. We didn't really talk about subscriptions, but subscriptions are real-time notification that you can get in your app. So kind of think about that. It's going through SNS, DynamoDB, and Translate, and still showing you all of these notifications in real time, right? I didn't write a single line of code on the subscription part. This is just something that just works out of the box for AppSync. So to do this, I did a couple of things that I'm going to try to show now. First, I talked about the fact that you can use libraries with And this is one of the things that I did here. I wrote my own library that I'm importing into my functions. So I knew that I wanted to use SNS, that I wanted to use Translate, and that I wanted to use DynamoDB. So what I'll show you here is that, and this code is all available on GitHub, and you can use the links into GitHub repo, and I'll put the link into app. But I essentially wrote a TypeScript library that is handling all of my requests so that I don't have to re-implement this in my JavaScript functions. The first one I wrote is a publish to SNS request that takes a topic and a bunch of values, and it returns an HTTP request for AppSync. So to do this, I'm essentially just returning a post request to SNS with a bunch of, with my parameters properly set up, made up of my parts. And this returns a post request, and I have the specific header that I need to use for SNS. You can find out about these headers by looking at the SNS documentation. I think in the near future, we will be doing a lot more of these where we create some of these libraries that allows you to talk directly with some of these AWS services. But for now, I did it here directly. And then I also wrote a function that handles the response. I did the same thing for Translate. So I have a function that that interacts with Translate, gets the response, and I have the same thing for DynamoDB. I have a function that just does a put. And then what I did is I published this library to NPM. I called it Brisk Handy AppSync library, and it's there. And then in my own code, I can import that code. Oh, where am I going? In my libraries, so I've got this mono repo where I've got a lot of things going on, but I've got a CDK app, an AppSync app, and my Next app. In AppSync, if I go to source and I go to functions, and here is my publish to SNS function, you can see that I'm importing my AWS AppSync utils, but I'm also importing my utility from NPM. So you can definitely use libraries from NPM. They just need to respect to meet the criteria of our AppSync.js runtime. And then when I want to upload this to AppSync, all I have to do is build it, right? I need to bundle it into a single file. And the way I do that is by using here, I used esbuild. So I'm going to make this a bit bigger. I simply have an esbuild command. I tell it to bundle. I tell it that the target is node 16, the platform is node, the format is ES module, and I tell it that the AWS AppSync utils library is external. The AppSync utils library is recognized by AppSync, so you never need to upload that with your code. This bundles everything into a single JavaScript file that I can then use to interact, to create my functions. So it's really easy to get started with JavaScript. It's just JavaScript, again, as I said, but it's really easy to do. If I take a quick look before we wrap up here at the CloudWatch logs, there's probably going to be a ton of stuff here. I don't know if people are trying to break this app, but it's not breaking. It's not going to break. In CloudWatch, you will see all of your results, and you will see the logs. For example, there's a lot of stuff here, but I added a log statement publishing messages to SNS, and this came at line 85 and column 3 of my code, and you can see everything that was done here. I can log back the response. This is the response that I got back from SNS. Say that I successfully published. Same thing, if I go down here, I will find more information about what I'm doing with transcribe. The main thing to know is that your logs are really easy to look at. No more trying to really squint and kind of understand what is going on, and it respects your logging level. So we've got 15 seconds here before the session ends. The last thing I'm going to say here is definitely go check out our RFC and let us know what you want to see next. The functionality, the feature is available now. We've got samples, we've got documentation, we've got all of that. But what do you want to see next? Let us know. Check out some of these presentations that are going on at reInvent if you haven't had a chance to look at that yet. And yeah, I think this is all I had. I just really want to thank you for being here and making the time for Ed and myself. You can find us here. These are our socials. Follow these QR codes if you want to have more information. I think that's all we had today, but I really want to thank everybody for coming, and we'll be outside if people have any questions.